all. So I think you can hear me today. We will continue our live coding series. So today is the third day. Okay. This is our notebook which we were doing in our last session. Okay. So let's come here. This is the notebook. So what we were doing in our last session, we were building the LSTM model which work for the character label. Okay. Character means these single character series it should work. So let's connect it first. So first we will revise first what we have done and then we proceed further. Okay. So set it is connected now. Okay. So first is dataset description. So I told you that we will work on Adventure of Sherlock Holmes. So this is one book and we are working on this complete book. Okay. Now next we import TensorFlow. We try to set TensorFlow version 2.x. Okay. So we try this code, try, and if error comes, then we ignore that error. Okay. Then we import sequential from TensorFlow. So from TensorFlow.keras.models, we import sequential model. There are two types of uh, models in TensorFlow. One is sequential and another is functional. So here we are using sequential. Okay. Then we import dense, dropout, and LSTM layers from TensorFlow. So we write from TensorFlow.keras.layers import dense, dropout, LSTM, and input layer. After that, we import model checkpoint from TensorFlow. So these checkpoints we use to save our model after a particular period of time, means after epoch we can say. So if we are doing high amount of training, so we should not lost everything after a certain period. So we are saving our model after a certain point so that later we don't need to retrain our model. We can take that checkpoint and from there we can start. So from TensorFlow.keras dot callback import model checkpoint. Now, in the last, we import two categorical. I explained you that two categorical is used to do one hot encoding of our target variable. Okay. So from TensorFlow.keras.utils import two categorical. Then we import other required libraries like NumPy, URL and system. Okay. Then we import the dataset. We use dataset is available at this URL at my GitHub repo. So URL lib.request.url open and we save this dataset in this response variable. So now comes first question: complete the function to read the text from response object. So for this, you can one second run this. Yes, and this one also. Okay, and after this, run this. So for this question one, you can see my last video. we discuss and write down this code. Okay, so I will just simply run this code. Here we created one read text function which take response as an argument, and then we do response.read.decode, and for decoding we use UTF-8, and then we convert our data to lowercase and save in raw text and return this raw text. Okay, so now we will run this function and save the output in raw text itself. So it is done. So we can see this part I have done in last video, so I will go quickly from for this part. Okay, so print raw text 0 to 1000. So this is the raw text to Sherlock Holmes, like this you can read. Okay, now what we do, we create characters, and what we do, we take a set of unique characters from raw text. Okay, from this complete text we take the unique characters, because set, what set do, it don't take duplicates, so it will remove duplicate characters. Then we create the list of those characters which come from set. Okay, list, and then we sorted the list using sorted function. So we run this, then comes the character, and we so these are the characters in our data. Okay, now come the question to create mapping of unique characters to integer. Okay, so our deep learning models work generally, means not generally, work with numerical data, means whatever is form of our data, it doesn't make any difference. We need to convert that data into numerical form. Okay, either it is text, speech, video, image, whatever form is there, we need to convert that into numerical form before feeding into our model. So we create this function def character mapping, and we provide input characters. So character to int. So what we do, dect c comma I for I comma c in enumerate characters. So we use this enumerate function of Python. So for every characters, it will assign index, and by using that index I, we created like c comma I, and we created the dictionary for whole. Okay, so this also I have explained in last video. So it will return character to int. Now run this function on characters and save in character to int. So this is the output of character to int. You can see. Okay. So this is the output. Okay. So you can see this character int start from 0 and then goes till 61. So there are total 62 characters here. Now, what we have done, we uh, check the complete length of characters in our input data, means complete. So raw text and length of raw text. Okay, okay, 1 second. Okay, here we created the raw text. Okay, from response we created raw text. Okay, okay. So we check the length of characters, total characters in our data, and store in n characters. Then we check the uh, length of unique characters, and that we call generally vocabulary. Okay, what is vocabulary? The unique characters in our data. So that is called vocabulary. What is the use of finding this vocab? Because when we create our model, so output of model will be the vocabulary. Okay, so output size of the model will be the vocabulary. So our model will give probability for all the vocabulary. Okay, so there are 62 words. So our output shape will be means size will be 62, and we will use softmax function there. So softmax function will give probability for all these 62 characters, and we will take the character which will have highest probability. So that's why we calculate here n vocab. Okay. So run this. So you can see that total characters is 561625, and total unique vocab is 62. Now comes the question number 3. Create input and output variables. So for creating input and output variables, what we are doing, we or you can say we did, we created the input sequence of 100 characters, and after 100 characters, our model will predict the next character. So we create one variable max length, and that will have 100 characters, and the step size will be 1. So after giving 100 characters, one output will come. So we will move one step forward. That since we are developing LSTM model, so that output will come as input, and in this way we keep on moving. So we created two things. One is sentences, two empty list. One is sentences, and another will be next characters. Okay, these two will be the thing. So for training purpose, we will fill these two lists completely. So our training data will be prepared. Okay, so run this. This part we have already done. I am just going through quickly. Okay. Then what we do, what we did, we create input output function. So to create the input output, so it will take raw text, is our complete input data, then max length and step. Okay. So here we use for loop to going through our input data and creating the sentences and next characters, or you can say our input data for LSTM model. So for I in range 0, we will start from 0 to length raw text, whatever will be the total length of our input data minus max length means 100. Okay, because here input sequence should have 100 words. So we are after means minus 100. Okay, because if input last limit is not uh, at least 100, then it will be the issue. Okay, and then we mention a step for this range function, that is 1. It will move one step forward, like it will take 100 words and next word will be the output, then we'll move one step forward. So it will take 100 characters and move one step forward. So then we do sentence dot append raw text, and using indexing, what we were doing, I2 means initially for first iteration, suppose I is 0. So 0 to I plus max length. So 0 to 100. So if you see that from 0 to 100, it is like 101 word. But in indexing, it won't take the last limit. Okay, so if 100 is there, so it will do till 99. So 0 to 99, it will be 100 only. So we will append this much raw text into sentences, and for that respectively, we in next characters here we append raw text and I plus max length. Okay, so For example, it is 0, so 0 plus max length, that is 100. So that will be the our uh, character for next character. That will become our y. Okay. Then we return these sentences and next characters. Okay. Now we run this function input output and raw text, max length, and step. So and save the output in sentences, comma next characters. So first run this function, then run this cell, and let's see how many number of sequences are created. Input sequences. So see 561525. Okay, so we will see the first 10 sequences. So these are the sequences. So this will come as input. Okay, this much come as input, and then here see next character. And so when this come as input, so this should be the output. Model will be played like this. And when this outcome will come, this will be added to input here. You can see that in mention. Oh, these are added. And then we predict next. So for next and is there. So that will be added to this one. Okay. So now a mention will come. So in this way, our sequence will move one step forward. So I hope now it's clear to you. Then then comes sequence length. So that is I think already mentioned. Okay, max length. Okay, so now again we are mentioning sequence length that is 100, and then we are creating two input images, that is data x and data y. Why we are doing this? Now we will convert our this data into integer values. Okay, so because right now it is in text, so we need to convert it into integer before giving it to the model. So for what, that's why we are creating two integers, data x and data y, and sequence length is 100. Complete the function to convert the characters to integer using character to int. So this is our next question. We need to complete the function that convert the character to integers using character to int. Okay. So we are defining character to int function here, and characters, sequence length, raw text, and character to int will be the arguments. So sequence length, raw text. So here also we will apply loop. So for I in range 0 to n characters. So how many characters are there? We calculated previously total characters in our input data here. Here we calculated n characters. So 0, comma n characters minus sequence length, that is 100, comma 1. Now we use character to int here. Okay. So sequence in will be raw text I to raw text I to I plus sequence length. Okay. And then sequence out will be raw text I plus sequence length. And then we use character to int function to convert our characters to integer, and then append those into data x and data y. So here data x dot append character to int for character in sequential. So there are 100 characters. So for it like list we use list comprehension here. Okay. So and for data y dot append character to int sequence out, and we will return these as data x and data y. So run this, then we run this function and save the output in data x and data y. Okay. Now we will see how many patterns are there. We already checked, but again they are doing. So length of data x total patterns. We already checked this when we are converting for text. Okay, so now we are converting to integer only, nothing different. So 561525 total patterns. We will see. We will print first two. Uh, See, so this is our first input 31, like this till here. Then come our next. So I think this come next. So two inputs are there. Then data y. So this is data y. Now that we have prepared our training data, we need to transform it so that it is suitable for use with keras. So we need to transform it so that it is suitable for use with keras. First, we must transform the list of input sequences into the form. So these are in the list form. So we will transform them into samples, comma, time steps, comma, features. So this is the format which is expected by LSTM network. Samples, time step, and features. So reshape X to be how many samples are there and patterns, and then time step, that is sequence length 100, and then features. So every step have one feature. Okay, so run this. So X equal to NP dot reshape data X comma and patterns comma sequence length comma 1. Okay, so if we will check X dot shape. So now this is the shape, total input patterns, and this is the sequence length of one pattern, and this is the features. Okay, so every in 100 every input has one feature like this 30, okay, 37 like this. So if we print 21x here, so you can see 31 like this. So now this is done. Next, we will now we need to rescale the integers to the range 0 to 1. Okay, so for now it is in the range 0 to 61. So we will rescale them to the 0 to 1 to make the patterns easier to learn by the LSTM network that uses the sigmoid activation function by default. So we will convert this into the range 0 to 1. So it will be, why we will do that? Because it will be easier for LSTM network to learn by 0 to 1 in compared to 0 to 61. And by default, LSTM uses sigmoid activation function. But here Our vocab size is 62. Its output have 62 classes. So we will use softmax acquisition function that I will show you later. Okay. Also for normalizing our data, what we do x divided by float and vocab. So we divide x with the float of vocabulary. So now this is our x. Okay. Finally, we need to convert the output patterns. Single characters converted to integers into one hot encoding. Then what we need to do, we need to convert the output patterns. Okay. What we need to do in that, single characters converted to integers into one hot encoding. So like we imported two categorical initially, na, that we will use and convert our output into one hot encoding. Okay. This is so that we can configure the network to predict the probability of each of the 62 different characters in the vocabulary and easier representation rather than trying to force it to predict precisely the next character. So why we are doing this? Because by doing this, we have 62 output means output variables categories in output variable. So we will find probability for all of them, and then we will take the character which has highest probability. We are not forcing our model to predict precisely the next character. Okay. So each y value is converted into a sparse vector with length of 62. Okay. So full of zero. So I hope you know what is one encoding. So all will be zero and except at one column where that value is present, that will be one. So same thing it is saying. Okay. So one hot and put the output variable. So y equal to two categorical data y. Okay. We do two categorical for data y and is stored in. Okay, let's run this. Now come y dot shape. So what is the shape? These are the rows and 62 columns. You can see it like this. Here it is the Y look like. Okay. Now uh, building the LSTM model. So let's check the shape of X. The shape of X. Now next question. Complete the function to build the LSTM model. So we are creating a function that will build the LSTM model. So tab build model. And first of all, we create sequential model. We create one object model and which contains sequential. So sequential model. So we will use sequential. Now model dot add input layer. We add input layer to our model and shape of the input layer will be x dot shape 1, that is 100, and x dot shape 2 1. Okay. So this will be the shape of input layer. Now we add LSTM layer. Model dot add LSTM and it will have 256 units. Now to conquer the overfitting, we use dropout 0.2. Dropout don't have any learning parameters. It is used just to, you can say, to reduce the overfitting. So it will uh, it will use like this only. Then model dot add. So we will use this is output layer in our model. So it is dense layer and shape will be y dot shape 1. So y dot shape 1 is 62. Okay, this is the y dot shape, so it will be the 62. So y dot shape 1 and activation will be the software. I told you that if we have binary class problem, we use sigmoid activation function, and if number of classes in our classification problem is more than 2, we use software activation function, and then we return this object model here. So run this code. Okay. Now we will run this function build model and save output in model. It is done now. Now we will check model dot summary. Okay, model dot summary. So here, see in our first layer LSTM we have total parameters 264192, and dropout layer will have 0 parameter. I told you it dropout layer won't have any learning parameter, and then dense layer will have 15934 parameters. Okay, so these are the total parameters and these are the trainable parameters, and there is not any non-trainable parameters in this model. Okay, now complete the function to compile the model. So we will we have completed we have write code to compile the model. So def compile model, and as a argument we take model. 1 second. So now model dot compile. Okay, and in this we mention loss. We use loss categorical cross entropy. Okay, and optimizer which we use here is Adam. So optimizer use this loss function to optimize. Okay, so now we return model. So run this part we have already done in our last video. Now model equal to compile model and model. Okay, and this next question is create a model checkpoint callback object. So we will create callback object here. Okay, so we have created. So file path will be the weights improvement epochs it, this much and loss point 4. So and we use dot garage. Okay. So here 0 2D means two digit. Okay, and point 4F means till the 4 points after dot. Okay, 4 figures after dot. So run this. This will be the file path. Now we create a function create checkpoint, and in this we take file path as an argument. So checkpoint will be model checkpoint. Checkpoint will be the model checkpoint. Okay, and file path will is there, and then we have monitor equal to loss. So we need to monitor. So we use loss for monitoring and save best only. So it will check if that value is best, only then it will save. So save best only equal to true, and mode equal to min means we need to consider minimum value or maximum value, means we are considering loss here for monitoring. So minimum value will be the perfect. So we use min here, and if we are using something else which have best value as a max, so we mention max there. Okay, and then return checkpoint. So this is the thing. 1 second. Okay. So see, I hope now let me cross check with my phone. Just a second. Okay. Just a second, guys. Let me check that my monitor is coming or not, because I have started recently only this videos. Okay. So I think I another window is not coming. I don't know for now how to do that. That is not coming. Okay, now it is coming. Okay, okay. So we will go in Keras first. Keras API layers. Okay, so here when we go in Keras, here in API, you can see callbacks API are there. Okay, so in these callbacks APIs, you can see these are the different callbacks APIs available here. Okay, so this is the model checkpoint. So if we are using this model checkpoint, so here we have file path which we have mentioned, then monitor what we want to monitor. Verbose means the output. It should be detailed or like short, and then save best only and save weights only, or you want to save the complete model. Then comes mode, that is auto. or min or max. Then save frequency means after how much time you want to save your model. Okay, so here it is mentioned like initial value threshold. So it is mentioned as null. So you can see that callback to save Keras model. One second. So callback to save Keras model or model weights. At some frequency. Okay. So model checkpoint callback is used in conjunction with training using model.fit to save a model or weights in a checkpoint file at some interval. So it is generally used with model.fit to save a model or weights in checkpoint file at some interval. So model or weights can be loaded later to continue the training from the state saved. Okay. So a few options this callback provides include whether to only keep the model that has achieved the best performance so far or whether to save the model at the end of every epoch regardless of the performance. So we need to means decide uh, means we need to save the best performance part means best performance model or we just want that after every epoch either it is best or not it should be saved. Then a definition of best, which quantity to monitor. So we we mentioned here monitor. So this is used to define the what is best mean. Okay. The frequency it should save at currently callback support saving at the end of every epoch. So yes, save frequency at the end of every epoch or after a fixed number of training batches. Uh, and then we have whether only weights are saved or the whole model is saved. So we will check we, only weights are saved or whole model will be saved. Okay, so this is the our model checkpoint API. So let's come back to here. So here, like this, we have create checkpoint function. File path monitor save based on true and mode minimum, and it will return checkpoint. And then we run this function create checkpoint, and file path will be the input which we have created here, and then save it into checkpoint. Okay. Now we will create the list of checkpoint and then store it into callback list. What why we have converted them into the list? Because our model will take them as a list only. So that's why we created the list of checkpoint. Okay. Now from here our work starts. Now it is asking complete the function to train the model. So we need to write the function to train the model. One second. Okay. So we will write for training, we use model dot fit, and here we use x, comma y, comma epochs. How many epochs we want to use? Suppose for now takes 20 epochs. Then comes the batch size. Batch size, let's take 128. Then the callback. Callbacks will be the list. Okay, so this will be the callback list. So let's run this. Okay, so what will happen? A fit will happen, and all the callbacks will be saved in this callback list. All the checkpoints will be saved in this callback list. Okay, so model equal to fit model and then model. So if we run this, okay, so it will take a lot of time. So means for now it will take like 10 to 15 minutes. So for now I am just not running this because we are streaming live. So if we will run this code, so this will happen. It will start with here, and in first epoch, these much are the steps and how much time it is taking for this for completing this epoch, and then so you can see 64 seconds, 60 seconds. So 20 epochs are there. So it will take approx 20 minutes. So that for that time we have to wait. I will show you the output. Okay. So then comes the 14 millisecond per step. So this is the time taken by the every step. These are the steps. Okay. And loss after this epoch will be the 2.8386. Then comes second epoch. Loss is reducing. Now it is 2.6491. Then loss is 2.5433. Then loss is 2.4618. 2 point like this. Loss is so after 20 epochs, loss is 1.9993. Okay, and then to see the list of all the weight checkpoints file created, those will be created here only. Okay, so ls, we use ls, so these are the files. These are the files, and you see that this file will have lowest loss, so we will use this file only. Then comes the next question: complete the function to load the model. So we need to write the function to load the model. Okay, so here desktop, here we save it. Okay, so let's extract this. Okay, do one thing, upload this file. or this file I can upload. Okay, again, let's upload this file. And, okay, because last time before coming to live, I have run this code. Okay, so and save this part because it will take 20 minutes, and later we create larger LSTM that will take more than 30 minutes. So that's why I have created this checkpoint. It is with file. I think it will take lot of time again. Let's see the property. Okay, it is 150 MB only. Then I don't know why it is taking lot of time. Wait, for this much time we have to wait actually. This file is uploading. We have to wait. I don't know why it is taking too much time. Okay. So now the question is complete the function to load the model. Okay. So use the wait checkpoint file that has the least loss value. So we will use this file name waits improvement this. Okay, so from here now def load model. We provide model and file name as argument, and then we write model dot load. Okay, load waits and then file name, and then it will return model. We will run this. Then again, what we do, we will after loading, we will do model dot compile, and loss will be the categorical cross entropy, and optimizer will be the atom. For now, we can also do one more thing. What I will do for quick. So from here, we will take this one. Okay. Actually, I am uploading only this file till this zip complete zip file is loading, so that we can proceed. Okay, so this is uploaded. Okay, so now we will run this code file name equal to this much, and then model dot node dates file name on this. Now we run a node model, and then model comma file name model equal to node model. Okay. So one warning is coming. Skipping variable loading for optimizer add-on because it has two variables, whereas the same optimizer has 12 variables. Then we do model.compile categorical cross entropy optimizer will be the add-on. Now, what it is saying, create reverse mapping of integers to character. So now we will do reverse mapping of integers to character because before feeding to models, we have converted all the characters to integers. Now it's time to revert them back so that user can understand them easily. Okay, so into character function characters. Now in character, same we take, and since we are doing into character now, I comma c or I comma c in enumerate characters. Okay, and return characters. So run this function into character function. We use it to into character. Now check the output. So it is for every integer, what should be the output? It is like reverse what we were doing before. So after this, we will use this mapping to convert the integers back to characters so that we can understand the prediction. Okay, same thing I was telling. Finally, we need to actually make predictions. Can pick a random input pattern as our seed sequence, then print generated characters as we generate them. It is saying that we are generating a random, picking a random seed here. So start equal to np dot random dot rand int 0, comma length of data x minus 1. So any one value from this will be taken. Okay. And that value we will pass to data x and save the output on the pattern. Now the seed. Okay, this will be the seed which we will. So the extreme limit of this region, then suddenly springing to his feet. He beat his head against. Okay, so this is the seed we will be providing to the model. So this is the code which I have run before. So for downloading the checkpoints, you can use this code. Okay, not an issue. Now we write down this function generating the characters for I in range thousand. So we will uh, generate thousand characters from our LSTM model. Okay, so x equal to nv dot reshape. Then in that we have pattern, comma one comma length of pattern comma one, and then we have convert means all the pre-processing steps which we have done till now. We are doing those only. Okay, so we are normalizing that. Then we are using model to predict, and then we do our max to find the what is like prediction, then result into character to convert it into character, then sequence in. So it whatever is coming, then will be at least passed to into character to find the characters, and then we will write result, and in the pattern we append the index and pattern like this. Okay, so this is the function. You can check it out, and the in general this function is asking the model to generate the 1000 characters for our seed. Okay, the seed which we are providing. So, and this you can see that it start generating our LSTM model start generating the output. Okay, and one thing you can see here that I am not I am using transfer learning means before starting this session I have trained my model, and that only I am using here. So you can see the beauty of transfer learning. I just saved file that time, so I just use those file only. Okay, so I just using those file only. Okay, so it is done now. This is the output. This is the output which is generated by the model. So it is like repeating something. I don't know. Okay. So now what we will do, we will build a large LSTM network. Previously, we have built a small LSTM network. This time we will build large LSTM network. And so complete the function to build the large LSTM network. So we will write code here for building the large LSTM model. What we will do, we will take more units in our model. Okay. So first of all, we will create model object and save sequential model in this. Then we will add ls. Then we will add model dot add input layer. We'll add input layer and then let's check input layer first. In layers, under core layers, this is the input layer. Okay. So here in input layer, we provide shape and batch size. Then data type is sparse, uh, ragged, batch shape, name, tensor, and optional. So we will provide shape only here. Shape will be x dot shape 1, comma x dot shape 2. Okay. Then we add model dot add LSTM in this. Okay. So this time we take 256 units in our LSTM model and return sequences will be true. Okay. Then we add model dot add out and fraction will be 0.2. Then uh, again we again add another LSTM layer model dot add LSTM 56 model dot add dropout 0.2. Then we add output layer to our model dot add and dance layer and then what will be the output shape y dot shape that is 62 from the activation function. Activation will be the max. Okay, so this is the complete function. We have input layer, then LSTM layer, then dropout layer, then again LSTM layer, then again dropout layer, then dance layer, the softmax activation function. So we will run this code, then we will run this function and save output in model. So This is the summary of our model. Okay, so LSTM1 has this much parameter, then dropout as usual don't have any trainable parameter. Then LSTM2 will have this much, then dropout 2 will have 0, and in the dense layer, or you can say output layer, we have this much parameter. Now model dot compile. So we will compile loss equal to categorical cross entropy, and optimizer will be the atom. Okay, so file path, we mention weights improvement epoch loss dash bigger dot keras. Okay, so checkpoint will be model checkpoint, file path, and monitor will be the loss, but both one saved as only true, mode will be the minimum, and we create a list of checkpoints and that will be saved under all track sales. Okay, now write the code to compile the complete the function to train the model. So bit bigger model. So we will complete the function to train the model. Model dot bit x comma y equals will be 50 this time, and let's see how much equals I have taken last time. 30. Okay, so equals will be 30, and the side will be what 512, and callbacks equal to callback list. Okay, so this is the function to train the model. Input data, data equals base size and callback equal to callback list. Okay, this. So, okay. Now this is the function to run the model. I am not running it right now, but if we will run, it will run like this only. Okay, import one. So if here we mention, see, if here we mention verbose equal to 1. So what does verbose mean? See, here it is mentioned equal 1. Loss improved from none to this much, saving models to weight improvement this. Okay. Then again, loss improved from 2.9629 to 2.7864, and saving model to weights improvement this. So like this, after every epoch, we will write. So this will show the list of all the files. Now, this is the code on which I use to mm, download these files before running this live. So now complete the function to load the model. So file name we will take weights equal to weights in file name this. So now So now write function, compile the function to load the model. We will write model load rates, then file and run this. Okay, so the set, let it upload. Okay, upload is done now. So run this code. Now load a bigger model. We will provide model comma file name and this code. Sequential object has no attribute, no fields. Okay, let's see what we have done before. Dot load. Let's okay, this spelling is wrong actually. So run this again. Then model dot load bigger model and then file name. So run this again. It will run this time. Okay, a total of one object could not be loaded. Example error message for object LSTM cell name LSTM cell equal to true. Layer LSTM cell expect three variables but received zero variables during loading. Okay, so this error is coming. Let's check with ChatGPT. ये एरर ऑप्टिमाइजर वर्डिंग की वजह से आ रही है मेन प्रॉब्लम ये है लेयर सेल LSTM cell expect three variables but receive zero variables during loading. Um, the model architecture waits we are loading. Match Okay, let's not resolve this in live coding. So this is some error which is coming. I will resolve it, and then we will compile the model, and then the same steps. These are the same steps which we have done for a smaller LSTM model. Okay, so we pick one random seed, and then we take input data on the basis of that random seed, and then generate 1,000 characters and see the output. And you will notice that output will be improved for larger LSTM model. Okay, so this is complete code for character level LSTM. I will upload this file, and if you like the video, please like and subscribe, and we will improve over time. Okay, so this is my third session, and